Alrighty, so let's have a think about how we can program a factorial calculator in C. So for those of you who don't know, factorial is quite simple. All it is, so for example, if you want to find the factorial of n, so it's represented by n followed by an exclamation mark, that is just equal to the summation of n multiplied by n take away 1. And this is a sum, and it's a sequence. So for example, if n equal to 3, so 3 factorial, or equal to 3 multiplied by 2 multiplied by 1, and it will go down to 1, and obviously that will be equal to 6. So knowing what a factorial is, I'll include a link where you can find further information what factorials are. Let's program this into C. So first of all, we just want to include a couple libraries, the first one being math.h, and the second one being stdio.h. Perfect. So let's just open our program up. Int main void open parentheses. Perfect. So to start off with, we're just going to define two variables called input, which we'll get from our user, and an I value, which is what we'll be using later in our for loop. Our last variable we need to define will be an unsigned variable. A good thing to note, the reason why it's unsigned is because factorials can never be negative, so therefore we can tell C that we're only really going to expect a positive integer. So with that, we can say unassigned long being because factorials can actually get quite large. So anything above 10 factorial will get increasingly exponentially larger. And let's just make that equal to result, and that's set by default to 1. And so result will be the evaluation. So for example, result would equal 6 in this case, if we were using 3 factorial. So next off, we just need to get an input from the user. To do this, let's just use a printf statement to start off with, and we're going to say enter an integer. Followed by this, we're going to include our scanf statement, and we're going to say %d as we're looking for an integer, and followed by, I'm going to assign this to the input variable that we defined up here. Perfect. So let's just run this, make sure there's no dramas. Yep, looks fine. So following this, let's do the logic of our program, and that's what's actually going to evaluate the factorial. For this, all we need is just a little for loop, nothing fancy. So in our for loop, we're going to say I is equal to 1, and then we're going to say when I is less than or equal to the input, plus I. So internally in our for loop, we're going to say result is equal to result multiplied by I, or this can be condensed down to multiplied equals I, which is pretty much the same statement. That is what that means. So to explain this a little bit better, I'm going to include a printf statement in here as well, and pretty much all I'm going to do is print the unassigned long variable that we put up here, so we can see what it's outputting every time this loops, and let's just make that equal to result. Perfect. And a new line now. What am I missing here? I'm missing what line is that on? 19. Of course, I put a comma. Alrighty, so let's have a look and see what this gives us. So for example, we enter the integer 3. This the first for loop evaluates to 1. That's because the result default value is 1 and I is 1. So therefore, when result equals result times I, 1 times 1 is 1. The next time it increases to 2, 2 times 1 is 2. The next time it increases to 3, 3 times 2 is 6. Once input is the same as I, the for loop knows to exit, therefore the factorial has been calculated. So knowing this, we don't really need to include this printf statement internally anymore. We can clean it up a little bit, put it outside, and we can say the factorial of %d is this, and we'll just put the input value so the user knows what they've done. So now, finally running the program, we can say 5. What is the factorial of 5? And the program simply says it's 120. And we can simply do that in our head. 5 times 4 is 20, times 3 is 60, times 2 is 120, times 1 is 120. Therefore, the program has done its job. So pretty much the limits of this program, it all comes down to this long unassigned variable. Testing this before, I found that you can't really go higher than 65. The integer 65 will give you this massive integer here, but if we want to go to 66, it will evaluate to 0 because this C can't handle that large of an integer. So I hope this video helped. If you wanted to improve on this, you could add some conditional statements so the user doesn't input a negative integer, as that can't be evaluated in Factorial. You could add some conditional statements to make sure that the user is putting in the correct data. And also you could put a while loop in here so it repeats until they have inputted a positive integer. Hope this helped. Thanks for watching.